So formula mass. We talked about atomic mass when we learned how to calculate the average atomic mass of an element based on the percent abundance and the masses of each individual isotope. We can also look at the mass of an individual molecule. This is going to use the average mass of the elements, and we're going to call this a formula mass. It's the mass of an individual molecule or formula unit. It's also sometimes called the molecular mass or the molecular weight. Molecular mass, mass of a molecule. Formula mass, it's the mass of the formula. That encompasses ionic and molecular compounds. So all we're going to do is we're going to look at the formula and we're going to see how many atoms of this element, how many atoms of that element, and we're just going to add up the masses of all the atoms in that formula unit or the molecule. So it's just the whole thing is the sum of the parts. So let's do an example. Calculate the formula mass of calcium nitrate. Well, you got to have the formula. So get a little practice writing a formula here. Calcium nitrate, what kind of a compound is that? Ionic? So we look at the first element, it's a metal. So this is an ionic compound. So we have to look at the ions. So calcium has what charge? 2 plus, because it's in group 2. Nitrate, we should have that memorized, NO3, the -1 charge. We look at the charges to see how to put them together. You can do the crisscross thing or the thinking about it. We're going to end up with Ca, and we need 2 nitrates to balance the charge on the calcium ion. So this is the formula. So we need the formula to calculate the formula mass. So in this formula, there's 1 calcium. There are 2 nitrate groups. That means there's 2 nitrogen atoms, and there's 6 oxygen atoms. So we're just going to add the masses of those things up. Calcium is 40.08. So we have 1 calcium, and it's 40.08 atomic mass units. And there's 2 nitrogens, and each nitrogen weighs 14.01 atomic mass units. And then there are 6 oxygens, and each oxygen on average weighs 16 atomic mass units. And so we're going to add those all up. And you just punch this through on your calculator, and your calculator understands. So I'm getting 164.1. And the unit there would be atomic mass unit. So then we have to, well, any questions about how I calculated that? And then we just have to say, well, what about significant figures? Because we always need to keep that in the back of our minds. There's different approaches to this. The most important thing is we don't want the number of significant figures in the atomic or the formula mass to reduce the number of significant figures that we have in a problem. And so what I've done here is I'm using the atomic masses rounded to 4 significant figures. And so then what I'm going to do is I'm going to make sure that the final result has at least 4 significant figures. It never hurts to have extras, but don't round this off to 164. They're not whole numbers, okay? Any questions? We've talked about molar masses of elements. We also have molar masses of compounds. It's the mass of 1 mole of a compound. The mass in grams of 1 mole of its molecules or formula units is the same number as the formula mass. So when we did this problem and we found the formula mass of calcium nitrate, 164.1 atomic mass units is how much one formula unit weighs. But if I have 1 mole of these units, it will weigh 164.1 grams. Okay? It's the same calculation, it's the same idea, but we've just made it on a larger scale. Okay, so what's the molar mass of ammonia? Well, what's the formula for ammonia? NH3. So ammonia is one of those compounds that goes by its common name. So you just have to remember what it is. So for NH3, we want the molar mass, that's the mass of 1 mole of this. So how much does 1 mole of nitrogen weigh? 14.01 grams. And we have 3 moles of hydrogen, and each mole of hydrogen weighs 1.008 grams. 14.01 plus 3 times 1.008 equals 17.034 grams. That is equal to 1 mole of ammonia. So sometimes we'll write this 17.034, that's a 7, grams per mole. What about sig figs? Well, this should probably only have 4. I'm going for general idea of sig figs, not picky details with multiplying and adding, because it's just a waste of brain power. We'll just save our thinking for other things. The nice thing about calculating molar masses is it's multiplying whole numbers, multiplying by whole numbers, and then a bunch of adding. And so we tend not to get a whole bunch of digital vomit here with all these different extra non-significant digits. At the most, you're going to get a couple extras, and so I usually just carry them along. So just like we use molar mass of an element to count atoms, we can use molar mass of the molecule to count molecules by weighing them. So if we have grams of compound A, we can calculate how many moles of compound A we have, and from that we can calculate how many molecules of compound A. Okay? And this is just dimensional analysis. This number, Avogadro's number, works with molecules and with atoms and with ions. So 1 mole is equal to Avogadro's number of molecules. And students get confused about that, and they tend to they sometimes put the number with mole instead. So this is what I would encourage you to do. So think of mole like dozen. Okay? So think dozen. And this crazy number is 12. And here we've got the molecules, those are eggs. They're the pieces. A dozen is 12 eggs. Is 1 egg 12 dozen? No. That's kind of silly, huh? So when you put the number, Avogadro's number with mole, that's as silly as saying that 1 egg is equal to 12 dozen eggs. A dozen eggs equals 12 eggs. So find the number of ibuprofen molecules in a tablet containing 200 milligrams of ibuprofen. And there is the chemical formula. So dimensional analysis. We identify where we're starting here. There's only 1 number given in the problem. Oh, I'm doing this in red. Okay. 200.0 milligrams. Milligrams of what? Milligrams of this. It's going to become more important that we label the substance that we're looking at. So we got milligrams of that, and what do they want me to find? Number of molecules. There's no abbreviation for that word. So I want to find molecules of C13H18O2. whatever. So we've got milligrams, we've got molecules, and we're like, Often, moles is in the middle. So if we put moles in here, could we convert moles to number of molecules? Sure we could. So let's put moles here. Can we convert milligrams directly to moles? No. But we can convert milligrams to grams, and then we can convert grams to moles. If you're having any trouble with problems like this, actually write the path out. It's very tempting to just jump to the equation, but if you don't have a clear picture of where you're going, you're going to get lost. Write out the path, and then it's easier. Okay, 200.0 milligrams of C13, H18, O2. And I'm going to convert this to grams, and then I'm going to convert it to moles, and then I'm going to convert it to molecules. And so then I fill in the units. I want milligram down here, so that cancels out. And grams down here, so those cancel. And moles down here, so that cancels. Remember, MOL is mole, and molecule, you got to write the whole stupid long word. Well, let's just start at the beginning. What's the relationship between grams and milligrams? Milli means what? 10 to the negative 3. So we know that milli stands for 10 to the minus 3. So there's milli on the bottom. I need the top and the bottom to be equal to each other. A gram is not equal to a milligram. So here I've got milli. I want to put what it means on the other side of the line. It means 10 to the minus 3. So 1 times 10 to the minus 3 grams is equal to 1 milligram. Milli is an abbreviation for 10 times 10 to the minus 3. What's the relationship between moles and grams? That's going to be different for every substance. We have to calculate that. That's the molar mass. We have the formula, so we can calculate that. So we'll just do a little side problem down here at the bottom, and I would encourage you to write these out. So 13 times the mass of carbon plus 18 times the mass of hydrogen. I'm getting these numbers from the periodic table in my head. And 2 times the mass of oxygen. So 13 times 12.01 plus 18 times 1.008 plus 2 times 16 equals 206.274 grams per mole. And because of the masses I used, it's going to have 4 sig figs. So 1 mole weighs that many grams. So I've got 1 mole of ibuprofen, and down here I'm going to put the number of grams, 206.274. The last term, molecules and moles. Molecules are like eggs, moles are like dozens. Where does the number go? On the top with the eggs, right? It's 12 eggs is a dozen. Avogadro's number of molecules is 1 mole. 6.022 times 10 to the 23rd molecules is 1 mole. We've got the long number and the long word on one side, the short number and the short word on the other side. So I've got 200 times 1 EE minus 3 divided by 206.274 times 6.022 EE 23. And I get a very large number. which if we're talking about numbers of molecules, numbers of atoms, it should be a big number. Before I start writing this down, I want to look at sig figs. This number has 4. My molar mass had 4. Avogadro's number had 4. This is exact. So I need 4 significant figures. 5.838. There's 4, 83, times 10 to the 20th. And so we would round that. So I don't know where I'm going to put that. I'll put it down here. We would round that to 5.839 times 10 to the 20th molecules. And then because it's likely to, get lost down there, I'm going to put a box around it. So it jumps out at me. Any questions?